Hi, I'm Mrs. Burns, and welcome to the last teaching lecture of Chapter 9. Today we are reviewing all about linear relationships. So we can see different patterns. Ooh, yours has the blank part. You can write in patterns. We can see different patterns in our table of values, and we can compare two sets of variables. We already looked at this over the past couple of lectures, and we can also use variables is the other word. We can also use words to describe how the variables are related, or we can show ordered pairs, or we can use expressions to show this relationship. So we talked about all three of those in 9.2. Now that you know how to make an expression, we can use that to calculate unknown variables. So let's look at our first example. Sound can travel 1,500 meters per second in salt water. This relationship can be expressed by the formula D equals 1,500 times T, where D means that that's just the distance that the sound travels in meters, and T is the time in seconds that it takes. So make a table of values. It can be hard to make a table of values unless you have a starting place. So I've started us off saying, please start at 0 time and distance, and then let's go up the time each 1 second. So if we have 1 second, then we're going to do the second, 2, 3, 4, 5, and 6 seconds is what we're going to look at. Now, to figure out what the distance is, it says, well, every single time you have 1,500 meters. So if you were to plug in here 1,500 and T equaled 1, 1,500 times 1 is 1,500. And if you just traveled another 1,500 meters for time 2, now you're at 3,000. If you add on each time plus 1,500, then you're going to get 4,500. And then 6,000 and 7,500 and 9,000. So each time we're adding on another 1,500 distance. So each second it moves another 1,500 meters. Now let's graph the data on the chart provided. So for this chart, I've already drawn in my lines, and I've also labeled my axes. On the y-axis here, I labeled this distance, and I put in brackets my units, meters, and then I put in thousands, because this way now, I can say, well, this is 0, this is 1,000, 2,000, so I don't have to write 3,000 every time. I can just write a 3, 4, 5,000, 5,000, 6, 7, 8, 9, 10,000. And for our time, I have seconds as my units in brackets. So I'm going to say 0 and then 1, 2, 3, 4, 5, 6. And then we also need a title. So I'm going to write speed of sound in salt water. Speed of sound in salt water. Underlined. So let's now figure out what all of these data points are. Our coordinate points, the first one is 0, 0. So let's draw a point 0, x, 0, y-axis. This is our x-axis with time. For 1 second, we go at 1,500 meters. So remember that this 1 means 1,000, this 2 means 2,000. So 1,500, 1,500 is halfway between, so I put it halfway between those two lines. At 2 seconds, we've gone 3,000. At 3 seconds, we've gone 4,500. At 4 seconds, 6,000. 5 seconds, 7,500. And finally, at 6 seconds, we've gone 9,000 meters. That's the speed of sound in the salt water. Now, that is our graph. Way to go. Can you have points in between these ones on your graph? For example, could you put a red dot right, say, here? Could you do that? Well, let's think about it. Why not? I would say yes, because I'm going to write B/C, which means because. Why can't you measure the distance that speed travels in 3.5 seconds? So you can measure the speed of half a second, because this gives us, it gives us the opportunity to measure the speed, or the distance, and speed at half a second. Great. Yeah, that would be wonderful to know that. Now, since we know that we can calculate it at 3.5 seconds, let's calculate what that distance is. Well, if we know that our formula is d equals 1500 t, we can actually just use it with the formula. We could also go, well, this was at 3.5. Let's look at where my dot is. It is about somewhere like here, maybe around between over 5,000 but under 6,000. But we could calculate it more precisely using the formula we were given. So we know that d equals 1500 t. So if t equals 3.5 seconds, then we can plug it in. D equals 1500 times 3.5. So if we add that into our calculator, you get 5,250 meters. And that's pretty consistent with what it says on our graph. So great. Calculate now the distance that sound could travel in the saltwater in 10 seconds. Same idea. We know the formula, so I'm going to write it every time. So even though you're going to do a few questions in a row like this in your homework, I would like you to do it like this every time. So in this case, t equals 10 seconds, so we have d equals 1500 times 10, and so our distance is 15,000 meters. Don't forget your units, please. All right, you're on the right track. Let's try an example the other way. What happens if we're given now an equation or a formula like this that has all these variables? What are we going to do? We'll use this linear equation to complete these following questions. So number one, make a table of values starting with x equals -1 and y equals 7. So how do we fill in all of these numbers? Well, I'm going to tell you that I want your x's to go up by 1 every time. So this will be 0, then 1, 2, 3, 4. And now we can figure out the y's by plugging in that value of x. So if we have x equals 0, then y equals -3. And for the x here, we're just going to write 0 plus 4. Anything times 0 is 0 plus 4, so y equals 4. So in this box, we're going to put y equals 4. We could even check that when x equals -1, here for that first one, y equals -3 times -1 plus 4. So -3 times -1 is +3 plus 4 equals 7. So that's how we got that number here, 7. Now let's do the next one. If x equals 1, then y equals -3 times 1 plus 4, because we're just plugging in the x values every time. We get -3 plus 4, so y equals +1. If x equals 2, then y equals -3. Plug in for our x is 2 this time, plus 4 equals -6. -3 times 2 is -6, plus 4 equals -2. If x equals 3, then we have y equals -3 times 3 plus 4, and we get -9 plus 4, and that gives us a value of -5. And last but not least, when x equals 4, then we plug in our equation. We know this part, but instead of x, we write 4 plus 4. -3 times -3 times +4 is -12, plus 4 gives us a value of -8. So that's how you fill out a table of values when you're given an equation. You just basically, you're going to plug in your x, and your value of x will change what y becomes. So each time that you get a value of x, you plug it into that slot, and that's how you figure out what the y will be. So now that you've figured out your table of values, you'll see that you have an ordered pair here, you have an ordered pair there and there. So let's graph these ordered pairs. I'm just going to scroll down, but you can still see it on your own. What I've done here is I've already written in all of the numbers. So each little box goes up by a value of 1. So remember that this direction in the x is positive, so this is positive 1, 2, 3, 4, 5, 6, 7, 8. To the right, going up is positive, so this is positive 1, 2, 3, 4, 5, 6, 7, 8. Going up to the left is negative, so this is negative 1, negative 2, negative 3, negative 4, negative 5 going left. And then going down is also negative, so going down this is negative 1, negative 2, negative 3, negative 4, negative 5, all the way down to negative 8 or 9. So let's look at this. We know all of the points. The first one was negative 1, 7. The next one was 0 for the x, 4 for the y. Then we had 1 for the x, 1 for the y, 2 for the x, negative 2 for the y. When x is 3, y is negative 5. And when x is 4, y is negative 8. So here are our coordinate points. Let's plug them in. When we have the x first and then the y second, we just follow along the x-axis, so this negative 1, and then go up 7, and we get a point right there. When x is at the origin 0, y is up 4. Then when x is 1, y is 1. When x is positive 2, you're going to have to go down y to the negative 2. When x is positive 3, you're going to have to go down to the negative 5 for y. And when x is positive 4, you have a y of negative 8. And so that's how you graph a line just like that. Now, what happens if you have an ordered pair where you don't know one of the values? So this ordered pair is just kind of like these guys, except for you only know one of them. Well, you can plug into your equation. The original equation was y equals negative 3 times x plus 4. You can plug in, this is the x value, and then you can figure out what the y is. So similar to what we did for our table of values, we have negative 3. In this case, x is 11 plus 4. Negative 3 times 11 is negative 33 plus 4. And that gives us a y value of negative 29. So y equals negative 29, and our coordinates are 11, negative 29. That would be our ordered pair and the value of y. Please have a read over these notes before coming to class tomorrow, and we will discover these ideas a lot further.